So this general trend is that people tend to using not only one hidden layer, you can have multiple layers, stacked together. And the idea is that they can create some kind of representation. So in the very beginning of the input, let's say this is X, this is Y, right? And this is sort of neural network considered as a function. In the very beginning, and maybe the feature you extracted in the hidden layer would be something like quite low level features. Then once you go to the later stage of the neural network, you tend to find this feature which is more high level, right? And also more semantically meaningful. And so this you can use it for like supervised learning, right? As we expand that, but also you can use it for unsupervised learning, and also people typically are using in like a parallel computation, and in the very early stage, and these like 2006 or something, that at that time still computing power is not that great, and also people in terms of all these tricks haven't been invented just yet. So training these deep neural nets is really, really difficult. What people did was, I think all these pioneer papers, if you're looking at this way they're doing it, either using some kind of unsupervised learning to create this kind of embedding, and then like either using this Boltzmann machines or using these autoencoder solutions. So here is RBM. Just quickly go through how this works. In fact, if you're looking at this, they don't have this directional links between like this input. This is input, and so this is sort of a hidden layer. So therefore, they make use of this sort of energy function to construct these your parameterized representation, and this energy can form as base in the building blocks to form a probability. So you can define that if I have this sort of observation, what is the probability this one of the hidden layer become 0 or not. And equally is that if you have this hidden layer sort of observed, then what is probability being sort of you can observe certain output from this neural network, and you can come up with a very efficient way to actually training that to obtain these parameters for the neural network. And so this basically creates some kind of building blocks for the deep learning network. And so I think the RBM being used for this recommender system. So this is sort of you can use this RBM, basically what to do is that you can create this some sort of embedding. So you start with, for example, image, and then you're building down this hidden layer, let's say 1,000 dimensions, and you do it again, right? To reduce that dimension to 500, and so on and so forth. So this provides a very good kind of unsupervised way to train these images. Once you got this code layer, you can using that for many interesting problems. You can do this not only for image but also for text as well. So you can show, in fact, that kind of unsupervised learning, and using that to build some sort of representation. It's it's quite meaningful. So you can also using this autoencoder, right, to create some kind of unsupervised learning to learn this hidden layer representation. So the autoencoder is the same thing, like it got input here, and output is say whether I could recover this same image, and then using this xi, x0 sort of differences as your sort of a guiding signal. to learn this hidden layer. So this is also people do that. Is that you build this sort of a hidden layer, using hidden layer to do this autoencoder, do it again, and create a multiple sort of layer.